In the last few videos, we have learnt about factorization of binomials. Now, let us learn factorization of polynomials. An algebraic expression of the form f of x is equal to a to the base n x to the power of n plus a to the base n minus 1 x to the power of n minus 1 plus etc. plus a to the base 1 x plus a to the power of 0, where a to the power of 0, a to the power of a to the base 1, a to the base 2 to the base n are constant, is known as polynomial with the variable x. For example, f of x is equal to 2x cube plus 3x square minus 4x plus 15 is a polynomial with a variable x. Similarly, in the polynomial f of x is equal to a to the base n x to the power of n plus a to the base n minus 1 x to the power of n minus 1 etc. to plus a to the base 1 x plus a to the power of a to the base 0, each of a to the power of n x to the power of n, a to the base n minus 1 x to the power of n minus 1 etc. a to the base 1 x and a to the base 0 is called its term, and a to the base n x to the power of n and a to the base n is not equal to 0 is called the leading terms, and a to the base 0 is known as the constant term. For example, in a polynomial 5x square minus 6x minus 8 and wherein 5x square minus 6x and minus 8 are its terms, and 5 minus 6 and minus 8 are coefficients of x square, x and constant term respectively. Similarly, a polynomial f of x is equal to a to the base n x to the power of n plus a to the base n minus 1 x to the power of n minus 1 etc. and a to the base x, a to the base 1x plus a to the base 0 is a degree is of a degree n if a to the base n is not equal to 0. For example, 5x cube plus 2x square minus 9x plus 8 and g of x is 8x square plus 12x minus 14 are polynomials of the degree 3 and 2, that is x cube and x square. Similarly, a polynomial of degree 1 is called a linear polynomial. Example, f of x is equal to ax plus b, where a is not equal to 0 is a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. Example, f of x is equal to ax square plus bx plus c, where a is not equal to 0 is the general form of a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. Example, f of x is equal to ax cube plus bx square plus cx plus d, where a is not equal to 0 is the general form of a cubic polynomial. Let us solve some examples using the following identities. Let us solve some examples. If f of x is equal to 2x cube minus 13x square plus 17x plus 12, find f of 2, f of minus 3 and f of 0. Given f of x is equal to 2x cube minus 13x square plus 17x plus 12, f of 2 is, you substitute 2 in the place of x, 2 into 2 whole cube minus 13 into 2 whole square plus 17 into 2 plus 12, which is 16 minus 52 plus 34 plus 12, which is 62 minus 52, that is 10. Similarly, f of minus 3, substitute minus 3 in the place of x, we get 2 into minus 3 whole cube minus 13 into minus 3 whole square plus 17 into minus 3 plus 12, which is again nothing but 222 plus 12, 222 minus 222 plus 12, which is minus 210. F of 0, substitute 0 in place of x, 2 into 0 cube minus 13 into 0 square plus 17 into 0 plus 12, therefore the constant term 12 is the remainder. Verify whether the indicated numbers are zeros of the polynomials with the following examples. Given f of x is equal to 3x plus 1, where x is minus 1 by 3, therefore f of minus 1 by 3 is equal to 3 into minus 1 by 3 plus 1 minus 1 plus 1, which is 0. So this is a 0 of the polynomial. Similarly, f of x is equal to Lx plus m, where x is equal to minus m by L. So f of minus m by L is nothing but L into minus m by L plus m, which is minus m plus m, which is 0. This is also 0 of the polynomial. Similarly, f of x is equal to 5x minus pi, where x is equal to 4 by 5. F of 4 by 5 is equal to, replacing x plus 4 by 5, we get 4 minus pi, which is not the 0 of the polynomial. The fourth example, p of x is equal to x cube minus 6x square plus 11x minus 6, where x is 1, 2 and 3. So let us take 1 first. P of 1 is equal to, replacing 1 for x, 1 whole cube minus 6 into 1 square, 1 whole square plus 11 into 1 minus 6, which is 1 minus 6 plus 11 minus 6, which is 0. So this is a 0 of the polynomial. P of 2 is, replacing x with 2, 2 whole cube minus 6 into 2 whole square plus 11 into 2 minus 6, which is 30 minus 30, which is also 0, and this is also a 0 of the polynomial. And now let us take P of 3, 3 whole cube minus 6 into 3 whole square plus 11 into 3 minus 6, which is 60 minus 60, which is also 0 of the polynomial. If x is equal to 2 is a root of the polynomial f of x is equal to 2x square minus 3x plus 7a, find the value of a. Given f of x is equal to 2x square minus 3x plus 7a, f of 2 is equal to, replacing x with 2, 2 of 2 whole square minus 3 into 2 plus 7a is equal to 0. That is 8 minus 6 plus 7a is equal to 0. 7a is equal to minus 2, a is minus 2 by 7. Similarly, another example, if x is equal to 0 and x is minus 1 are the roots of the polynomial f of x is equal to 2x cube minus 3x square plus ax plus b, find the value of a and b. F of x is 2x cube minus 3x square plus ax plus b, which is given. F of 0 is, you substitute x with 0, 2 minus 3, 2 into 0 minus 3 into 0 plus a into 0 plus b, that is b is equal to 0. Now f of minus 1, 2 into minus 1 whole cube minus 3 into minus 1 whole square plus a into minus 1 plus b, which is minus 5 minus a plus b, and a is already 0, minus 5 minus a is equal to 0, therefore a is equal to minus 5. Find the integral roots of the polynomial f of x is equal to x cube plus 6x square plus 11x plus 6. Let f of x be x cube plus 6x square plus 11x plus 6. Clearly, f of x is a polynomial with integer coefficient and the coefficient of the highest degree term, that is the leading coefficient is minus 1. Integer roots of x are, f of x are limited to the integer factor of f of minus 6, which are plus or minus 1, plus or minus 2, plus or minus 3 and plus or minus 6. We observe that f of minus 1 is minus 1 plus 6 minus 11 plus 6, that is 0. F of minus 2 is also 0 and f of minus 3 is also 0. Therefore, minus 1, minus 2 and minus 3 are the integer coefficients. Let this assignment be solved, and in case of any doubts, you can subscribe to my channel. In the next video, we shall learn factor theorem, factorization of the polynomials by using the factor theorem, and remainder theorem.